Welcome back. So this is really video number 3 of quadratics. So I did a video number 1 and a video number 2 that kind of was an intro to graphing quadratics. If you did not watch those, you must go back and watch those. This is a spin-off of understanding video 1 and video 2. So chapter 9, video 1 and video 2. One was standard form graphing and one was vertex form. So this is going to be the quick version of that, and I don't think anyone would be properly prepared for that. So please go back and watch video number 1 and video number 2. So let's get started. So this is our in-class worksheet, 9.1b. You can tell it's graphing. I can tell that this one's in what we call standard form. How do I know that? I don't see parentheses. Okay. Standard form as well, because I don't see parentheses. Let's look at the next two. Standard form, vertex form. I see that parentheses in there. And again, if you didn't watch video number 1 or video 2, go back, because what I'm talking about doesn't make sense. Please go back and watch those videos. Thank you. Questions 5 and 6. Both vertex form. How do I know? Parentheses, my friends, parentheses. Flip this sucker over. Bloop, bloop. Ooh, I tried to be all sneaky with you. This one is standard form. This one's got a little twist. It's actually vertex form because I see a parenthesis. And then, we got the vocabulary extravaganza. What is a vertex? What are zeros? What is an axis of symmetry? What's a minimum or a maximum and that value? What's the domain? What's the range? And the domain interval when the function is increasing or decreasing. You're like, what the heckers, right? I know, it's a lot. Math is its own language, come on, right? It's a beautiful language, just like any other language, it's beautiful. But if we don't understand the vocabulary, it's like a hot mess. So we need to understand the vocab that's coming at us so we're not like, what the heck? What's she talking about, right? That's some nonsense. Well, it's because we don't understand the vocab. The math is okay, I promise you. But you got to understand the vocab before you get to the math part. So we're going to practice the vocab as well. All right. Okay, so let's go back to the notes on the front. Cool beans, hello. Trying to get this straight. It's the most difficult thing I've done all day. Okay, that's good enough. So let's look at this first question. Hello. So start thinking about that parent function. Remember, it starts at 0, 0, 1, 1, and 2, 4. This one's the parent function. I see it. You're like, what the heck is that notation? This is function notation. Instead of using y, like y equals all this, they're using something called f of x. F of x is the same thing as y. It's just letting us know in advance, hey, what you're about to see is a function, and it would pass the vertical line test. For every input, there's a single and unique output. Okay. You didn't need to know any of that, Ms. Miller. Cool beans. Okay, you can think of that as a y if that makes you feel better, okay? So we know that our parent function is right here, right? You don't have to draw this, but I'm just showing it to you. We know that's our beautiful parent function, our beautiful starter parabola, and that's right here, y equals x squared. But we're gonna shift this sucker up 3. So I'm gonna take that vertex of 0, 0, and I'm gonna shift it up 3 problems, or three little bits, and you're gonna do the same. So let's do that. Cool beans. So here's my vertex of my parent function, but this is saying take that parent function and shift it 3. 1, 2, 3. And now we just go back to our pattern. 1, 1, 1, 1, 2, 1, 2, 3, 4, 2, 1, 2, 3, 4. Do we have a parabola? Yes, we do. Did we shift it up 3? Yes, we did. Did we ace this? Heck yeah, we did. Okay, now here's the vertex right there. Okay, cool. Let's go to question number 2. Question number 2. So there's our parent function. You're like, ooh, I see what you did there, Miss Miller. I know, that's pretty snazzy. And then I screwed it up. Come on, worksheet, work with me. There we go. So there's my parent function. That was pretty good, huh? There's my parent function. But this time, oh, shenanigans. I'm going to flip it down and I'm going to shift it down. Ooh, okay, all right, okay, I can do this, Miss Miller. Let's do it. So we're going to shift it down. So we still have the same beautiful little vertex. And remember, if we just flipped it, it would look like this. 1, 2, 3, 4.
Attention Cougar family, this is a tardy sweep. Teachers, please lock your doors and require students to show their detention slip to enter. Again, this is a tardy sweep. Teachers, please lock your doors and require students to show their detention slip to enter.
That just lets you know that this really is a live video. Okay. By the way, it's a tardy sweep. Get to class, kids. My gosh, stop being tardy. Okay, so if all it asked was y equals negative x squared, that's the graph. But not only did it ask us to flip it down, it wants us to shift it down too. So we're going to take that and shift it down to into the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Nice. Okay, so we're going to shift it down too, and then we're going to do the same pattern. Let's make sure we did that correctly. Did we shift it down? Check. Now remember, when it shifted downwards, it stayed at that vertex point of 0, 0. It just literally flipped over the x-axis. And then it shifted down too. Cool. Nice. Let's do the next ones.
Visit Ms. Roach in E3 or Ms. Harrington in F2 if you have any questions. Applications are due on April 1st. Matilda the Musical is this week on Wednesday, Thursday, Friday, and Saturday at 7 p.m. There's also a matinee on Saturday at 1 p.m. The links to buy tickets can be found by scanning the QR code on the Matilda posters around school.
Okay. So this is going to shift down. It's going to flip down, excuse me, and then it's going to shift upward. So I know with my parent function, the vertex is 0, 0. When I flip it, it's still 0, 0. But then it wants me to shift it up 1. Now this is a downwards flipped parabola. So we're going to go 1, 1, 1, 1, and then 2, 4, and 2, 4. Beautiful. Did you get it? Cool beans. And again, if you still didn't watch videos number 1 and number 2, go back and watch them. Okay, cool beans. And number 4. Number 4. Ooh, vertex form. I can tell. The parentheses are a dead giveaway. So, is this guy going to shift down? It's not going to shift down. I don't see a negative in the front. We do the opposite of this guy. So that's a positive 3. And then we're going to go up 1. So my vertex, my new vertex is 3, 1. So remember, my parent function vertex is 0. 0, 0. Go back to the original parabola. Now we're going to go over 3, bloop, 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 and up 1. Deja vu, I think I did this one in one of my first videos. Okay, and then we know it's not going to shift down, so we're going to go with our same pattern and go in an upwards direction. 1, 1, 1, and 2, 4, and 2, 4. Looks beautiful to me. Cool beans. I would suggest that at this point, you pause the video and do 5, 6, 7, and 8 on your own. Go. Five, 6, 7, and 8 on your own. Did you do them? Are you back? Cool beans. Let's check. Okay. So question number 5. It's going to be flipped downstairs. That negative tells me flip it over that x-axis. And then my new vertex is going to be the opposite of what I see here. So that's positive 2, negative 2. So from the origin, we're going to go positive 2 and down 2. Cool. And then we're going to flip it. So the same pattern, 1, 1, 1, 1, 2, 4, 2, 4. Look at us go. Cool beans. Next one. Question number 6. So, is it going to flip down? No, I don't see a negative. And we got to talk about what our vertex is. Our new vertex, instead of 0, 0, where is that really important point shifting? So we're going to do the opposite of this guy that's in parentheses. So that's going to be a negative 2 and negative 3. So my new vertex, start at 0, is negative 2, bloop, and negative 3, bloop, bloop, bloop. Let's double check. Did this stay up or does it flip and go down? It stays up. Cool. Let's go 1, 1, 1, 1. Cool. And let's go 2-4. And his partner in crime on the other side, 2-4. Cool. Now, again, if you haven't done 7 and 8, give it a try, right? If I was your soccer coach, I can't talk you to be a soccer player. You have to get outside and be a soccer player. And I'm not a soccer player, so no one's going to follow me on the soccer field. But, so, here we go. Let's flip this sucker over. Here we got it. Ooh, Miss Miller's trying to be snazzy on this side. So I gave you a standard form one and a vertex form one. You know what to do? Do you? Do you? Do you? Do you? I'm the best kind of peer pressure. It's math peer pressure. Okay, so here's my parent function, y equals x squared, but this sucker says shift it downwards. So we're going to go from the origin, 0, 0, and shift it down 3. Does this guy get flipped down? Does he go downwards or does he stay upright? How can we tell? You got it. Do I see a negative in the front? Mm-mm. It's going to stay upwards. Now, if there was a negative in the front, we just flip it down, right? Okay, so we're going to go with the same pattern, 1, 1, 1, 1, and 2, 4, and 2, 4. Killing it. Okay, last one. Let's check out this guy. Number 8. Oh, this one's a little trickster. Miss Miller did good. Good job, Miss Miller. Thanks. Okay, so this is my worksheet. I did make this. It's a good one. So let me scooch it down just a wee bit. It's definitely vertex form, but what the heckers? Okay, so I see it's going to be flipped downwards. I see that. I see that there's a horizontal shift. Where the heck's my vertical shift? I don't see anything here. If I don't see anything here, there is no horizontal shift. It doesn't go up or down. This one only goes side to side. Well, what the heck? Let's see what that looks like as a vertex. So I know we do the opposite of this guy, and we have no up or down shift. What the heck would that look like? What would I put here? No up or down shift. What the heckers? 0. You got it. Good for you. Okay, so here we are at the origin. That's our 0, 0 of our parent function. Now we got to go find that point. It shifted right yonder. That's it. There was no up or down shifting this time. It just shifted left or right. And again, it's the opposite of what we would think it would be, because my brain thinks this is a right shift, but I have to know it's a left shift. It's the opposite of what I see. And then now, ooh, the sucker's going downwards. So let's, cool beans. Nice. Did you get that? Nice. Okay, so come back for, I just dropped my marker tip. Come back for video 4 and we'll do the last little tidbit. I'm proud of you. You got this. Bye.